In lesson 6.5, we're going to look at equations that involve exponents, and this isn't your regular order of operations type of equations. This is when the exponent is the variable. So we're going to call these exponential equations because the variable is in the exponent. And that's what I filled in this blank right here. So the property of equality for exponential equations says that two powers with the same positive base, so they have the same base, are equal if and only if their exponents are equal. Now, this probably seems really straightforward to you because when you look at this expression right here, this equation, 2 to the x equals 2 to the 5, it shouldn't be really that difficult for you to understand that x must be equal to 5, because if they're equal, then the exponents must be the same because the bases are the same. Now, for the purposes of this lesson, we can only solve them when they have the same base. You are going to learn about these things called logarithms when you get to more advanced math, and that's how you would solve things like this when the bases are different. But for the purposes of this lesson, they must have the same base. So you can see that both of these have a base of 2. So let's start off simple, and then we'll get a little more complex towards the end. So we have 3 to the x plus 1 equals 3 to the 5. So since they have the same base, that means that x plus 1 must be equal to 5. So then obviously then x is 4. Now, just like regular equations, you can take x equals 4, you can plug it in up here and do the calculation. And even if you get like a weird, crazy number in your calculator, as long as you get the same weird, crazy number, you know you're correct. Now, when we look over here at a letter B, this first piece doesn't have an exponent, but remember that if it doesn't have an exponent, it's a 1. So that means that 1 equals 2x minus 3. And so then you solve, and you get x equals 2. And again, you can plug that in, and you can check to see that you got the same number. Last one. Remember, if the bases are the same, we can ignore the bases, and we can just look at the exponents. So that means that 3x is equal to 2x plus 3. So then x is equal to 3. Now, like I said, you can only solve these when the bases are the same. So if you look down in example 2, we have some expressions where the bases are not the same. So you might say, oh, well, I can't solve that. The way that you can solve it is by making the bases the same. So in order to do this, we must first change each side. Well, maybe not each side, but at least one side. To have the same base. So what does that mean? Well, 5 to the x equals 125. So what we have to do is we have to think of our powers. 125 can be changed to 5 to the third. So if you can make it so that way they have the same base, then you can do what we did up top where we made the bases the same. So now that 5 to the x is equal to 5 to the third, that means that obviously then x is equal to 3. So the first step is to check to see if you have the same bases. If you don't have the same bases, then you make one of them match by doing something with exponents. So when we look at example B, we have a 4 and a 2. Now 4 is 2 squared, so I can change it to have a base of 2 by rewriting it as 2 squared to the x. So what I'm doing is I'm replacing the 4 with 2 squared. Now I use my mad spam rules, which is to multiply 2 to the 2x equals 2 to the x minus 3. Now that I've made them have the same base, I can ignore the bases and just write an equation with the exponents. So that means that 2x is equal to x minus 3. So then when you solve, you get x is equal to negative 3. Letter C is a little more complex because I can't make the 27 turn into a power of 9 because 9 to no friendly power is 27 and vice versa. But what you can think about is 9 and 27 are both powers of 3. So we're going to think of our powers. 9 is 3 squared, and 27 is 3 to the third. So we're going to practice with our powers. And now it's 9 to the x plus 2. And then we have 27 to the x. So all I did was I replaced the 9 with 3 squared, and I replaced the 27 with 3 to the third. Now I do my mad span properties, and I get 3 to the 2x plus 4. Be careful, you have to distribute. And then that equals 3 to the 3x. Now that they have the same bases, I can ignore the bases and make an equation with the exponents. That gives me x equals 4. All right, we're going to kick it up a little bit more. And now let's look at ones where we have fractions, right? The dreaded F word. So here's my tip. Take care of the fraction first, and then worry about changing the base. Here's what I mean by that. 1/2 is also 2 to the negative 1. So I have 2 to the negative 1 to the x equals 4. All I did was I rewrote 1/2 as 2 to the negative 1. Now I'm going to rewrite that. I have 2 to the negative 1x, and 4 is 2 squared. So now I have 2 to the negative 1 equals 2 squared, and since the bases are the same, I can ignore the bases and write an equation with the exponents. So I have negative 1x equals 2, so x is equal to negative 2. So first you just deal with the fraction, and then you change the base. All right, let's look at the fraction first. In letter B, I have 64 to the negative 1. And I'm going to bring down 4x plus 1. Oh, now 64 is a power of 4. It's actually 4 to the third. So I can rewrite this as 4 to the third to the negative 1 equals 4 to the x plus 1. So now I'm just going to follow my mad spam rules. I'm going to multiply 4 to the negative third equals 4 to the x plus 1. Now that I have the same base, I can ignore the bases and just deal with the exponents. So that gives me x is equal to negative 4. And again, if you're not sure, take negative 4, plug it in up here. You get 4 to the negative third on the left. And if that equals 1 over 64, then you know you did it. Now, like I said, sometimes you can't create the same base. And you're going to look at logarithms in upper level math to solve equations like that. But another way that you could do it is to graph each side of the equation and see where they intersect. So if we go down to look at the equations at the bottom, you see that we have a 2 and a 7, and those can't be made to have the same base. We've got a 3 as a base, and this isn't even an exponential expression because the variable is not in the exponent, so those definitely can't have the same base. So we're going to look at how to use the graphing calculator. I'll save a little time in class when we meet to show you how to do it. And if you have any questions, write them down and ask me when you come to class.